We're starting section 1D on solving quadratic equations today, and I wanted to remind you of this graph that we did back in section 1B, y equals negative x squared plus 2x plus 5. We graphed that by plotting points, and I suggested at the very end of that class that this might be the trajectory of a human cannonball as he gets shot out of the cannon. And in this section, we want to answer the question, where should we put the net on the ground for this human cannonball? And just eyeballing it for my graph, I clearly want the net to be somewhere in between 3 and 4. But how do we calculate that exactly so that we know precisely where to put the net to catch the human cannonball? So that spot is actually just the x-intercept of the graph. So we want to find the x-intercept of this equation. And we find x-intercepts by letting y equal to 0. So I would say 0 equals negative x squared plus 2x plus 5. And that's a quadratic equation. A quadratic equation is just one that's got an x squared term in it, nothing higher. And we usually write this as ax squared plus bx plus c equals 0. And it has to be equal to something to be an equation that we want to solve. And we're trying to solve that for x. And we've got lots of different techniques that we use to solve quadratic equations. So eventually we're going to cover all 4 of these methods for solving quadratic equations. In the video, we're just going to talk about factoring and taking square roots. And then when we get together in Zoom, we'll talk about completing the square and the quadratic formula. Factoring and taking square roots are actually the easiest 2 ways to solve quadratic equations. The trouble is that they only work some of the time. So factoring only works if you have a quadratic that's factorable. So this only works if it's factorable. The second method, taking square roots, that only works if that bx term in the middle is missing. So if it's just an x squared term and a number, then we can use square roots to solve the equation. So this hardly ever works. But if the bx term is missing, then that's probably the easiest of the 4 methods to use if you can use it. So we're going to solve this one by factoring x squared plus 2x minus 15 equals 0. And you solve by factoring just by factoring. So I'm going to go about factoring x squared plus 2x minus 15. So since there's no coefficient on the x squared, I just need to look for numbers that multiply to give me negative 15 and then add to a positive 2. So how about we do plus 5 minus 3. Those multiply to give me negative 15 and they add up to a positive 2. And then factoring makes use of what we call the zero product property. Let me write this one down, the zero product property. And this says if you've got 2 things that are multiplying by each other to equal 0, then one of those 2 things has to be 0. So we say if you've got a times b equals 0, then either a has to be equal to 0 or b has to be equal to 0. That's the only way you can multiply 2 things and get 0. So since I've got 2 things multiplied here, x plus 5 and x minus 3, and it's equal to 0, that means that one of the 2 of them has to be equal to 0. So once you've factored your quadratic, you set both factors equal to 0. So I'm going to set x plus 5 equal to 0 and x minus 3 equal to 0. And then you just solve those 2 little linear equations. We're going to subtract 5 from both sides. So I get x equals negative 5. And over on the right, I'm going to add 3 to both sides. And I get x equals to 3. So this quadratic equation has 2 solutions, negative 5 and positive 3. All right, and this one kind of came pre-rigged, set equal to 0 for us. You have to keep that in mind when you're solving by factoring. The equation has to have 0 on one side, otherwise you can't use that zero product property. One more by factoring, we've got 2x squared minus x equals 3. And remember I said if we're going to solve by factoring, we have to have 0 on one side. So I'm going to subtract the 3 from both sides so that I get 0 over here on the right. So I'm going to have 2x squared minus x minus 3. All right. However you factor quadratics, go ahead and do that. I'm going to factor this one by grouping. We talked about that one in class. So for grouping, I'm going to take my a and c, my 2 times negative 3. We're going to get negative 6. And I want to find things that multiply to negative 6, but add to negative 1, the coefficient of the x. So that's going to be a negative 3 and a positive 2. So we write this as 2x squared minus 3x plus 2x minus 3. And then we do our factoring by grouping. So we group these 2 together. There's really nothing other than an x that I can pull out of that first group. So x times 2x minus 3. And there's nothing I can factor out of 2x minus 3 other than a 1. So I'm going to say plus 1 times 2x minus 3. And then we factor the 2x minus 3 out of both terms. So I'm going to get 2x minus 3 times x plus 1. And again, I don't care if you can just factor that by looking or if you have a box method or whatever else you want to do. I just factor these by grouping for you. However you get there is fine by me. But in the end, we end up with two factors multiplying to give us 0, which we make use of the zero product property, set both little linear factors equal to 0. So 2x minus 3 equals 0, and x plus 1 equals 0. And then those are pretty easy to solve, just linear equations. I'm going to add 3 to both sides. Get 2x equals 3, and then divide by 2. And I get that x is equal to 3/2. I'll go put that over here in my solution set. And I'll get one more solution from the x plus 1 equation. So subtract 1 from both sides. And I get x equals -1. And that's my second solution. So that's it for factoring. We spent a lot of time on factoring. Always just get 0 on one side. If you can factor it, go for it. If not, then you got to look for another method. So back to our cannonball, does factoring help us to solve this equation? So I would set this equal to 0. So I'd say 0 equals -x squared plus 2x plus 5. I don't like to factor when the x squared term is negative, so I'm going to divide everybody by -1. And I get 0 equals x squared minus 2x minus 5. And then we said about trying to factor it. So I'm going to say 0 equals, I don't have a coefficient on my x, so I don't need grouping. I want things that multiply to give me 5 and that add to give me a -2. And here's where this kind of falls apart, because the only thing that's going to multiply to give me 5 is 5 and 1. And there's no way that I can make that combine to give me a -2. So this quadratic equation just doesn't factor. Right? So we need a different method for this one. We're not ready to find where to put the net for our poor human cannonball. We're going to solve one equation by taking square roots. I mentioned that this is not usually a viable option for solving quadratic equations. It only works if you're missing that x term in the middle, like this equation, 3x squared minus 15. There's no like 2x in the middle of that equation. So if you have just the x squared and the constant term, then you can isolate the x squared. So to do that, I'm going to add 15 to both sides. And that gives me 3x squared equals 15. Also get rid of that coefficient. We're going to divide off the 3. And then that leaves me with x squared equals 5. So now we can just take the square root of both sides. So we take the square root, take the square root, and let's see. That gives us x equals, maybe you remember from high school, anytime you take the square root of both sides of an equation, you have to put a plus or minus on your answer. And square root of 5 is not anything pretty, so just leave it as the square root of 5. Don't bust out a calculator and give me a decimal. If I want a decimal, I can do it, but just leave it as plus or minus the square root of 5. And the plus or minus comes from, it might be easier if we think about a perfect square. Like if, for example, you had x squared equals to 25, right? Then x could be 5, because 5 squared is 25, but x could also be -5, because when you square negative numbers, they become positive. Right. So anytime you take the square root of both sides of an equation, you have to put a plus or minus on your answer. All right, so let's take a look at our poor human cannonball again and see if we can figure out where to put his net. So we had this equation set equal to 0. And this is not going to work by taking square roots, and I'll show you why. I mentioned that we had to be missing that x term in the middle. So we have an x term in the middle, but even if I tried to solve this by square roots, if I added that x squared to both sides to isolate the x squared like we did in the last one, you would end up with x squared equals 2x plus 5. And then when I try to take the square root, I end up with an x in my answer. So even if you tried, this looks awful to a mathematician's eye, but if you said x equals plus or minus the square root of 2x plus 5, you have an x in your answer for x. It's like using a word in its own definition. It's meaningless. Okay, so we cannot use square roots when we have that x term in the middle. So if you were copying that down in your notes, erase it, put a big X through it. We never want to try to use square roots when we have an X term in the middle.